In this video, we will be finding measures of central tendency, which are mean, median, mode, and mid-range from a data set. These are ways to find the center of a set of numbers. The first one we're going to talk about is the mode. The mode is the data value that occurs the most often in the set of data. So remember that mode kind of sounds like most. So the number that shows up the most. There can be more than one mode. If there are two modes, the data set is called bimodal. If the data set has more than two modes, then the modes may not be statistically significant. If no value occurs more frequently than any other, then there is no mode. So let's look at an example. We're going to find the mode of the following list of numbers. So we want to figure out which number shows up the most. And I would say there are 3 12s, and no number repeats more than 3 times. I have 2 8s, but I think 12 is the winner, showing up 3 times. So the mode is equal to 12. Notice I did not put the numbers in order from least to greatest. I did not need to, but I could have. It might have made it easier to find the mode, but I don't have to do that. Next, the median. The median of a data set is the central value of an ordered distribution. To find the median, you're going to order your data values from smallest to largest. If you have an odd number of data values, the median will be the number in the middle of your list of numbers, and there will be one number in the middle. If you have an even number of data values in the distribution, there will be 2 middle numbers, and you'll add them together and divide by 2. So go ahead and pause the video and try number 2. Start by putting the data values in order from least to greatest, and then find the number that falls in the middle. So hopefully you had a chance to try that on your own. I've listed the numbers from least to greatest. Now, when you first learned how to do this back in, I don't know, elementary school or middle school, they probably told you to cross one number off at the beginning and one at the end, and then another pair at the beginning and end, and another pair at the beginning and end, until you get to the middle. Now, that way is okay for small sets of data, but there is a better way now that we are in 12th grade. You always want to make sure that you have the same number of data values above and below. So triple check that you have the right number of data values in the set. I had 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers when I rewrote them in order, just to make sure you didn't miss any. And then I had 4 below the median and 4 above, so I'm pretty confident that 19 is the median. And again, since there was an odd number of data values, there was one number in the middle, and that's my median. Now, a fancy way to find the position of the median is using this formula right here. You take the number of data values, add 1, and divide by 2, and that will give you the position of the median. So in this set of data, we had 9 numbers. So if I do 9 plus 1 divided by 2, I get 10 divided by 2, which is 5. That means the 5th data value is the median. And if I count 1, 2, 3, 4, 5, that median that I circled was the 5th number. Okay, so go ahead, pause the video, and try number 3. Okay, so hopefully you at least listed them in order from least to greatest. Now let's try that position formula again. This data set has 12 numbers. So if I do 12 plus 1 divided by 2, I get 13 divided by 2, which is 6.5. This means that the median is going to be between the 6th and the 7th data values. So if we count in 1, 2, 3, 4, 5, 6, 11 is the sixth data value, 12 is the seventh. And this data set has an even number of data values, so those are the two middle numbers. And I have to, in this case, when that happens, add them together and divide by 2, which gives me 23 over 2, which is 11.5. And that's my median. Next, we're going to find the mean, which is often called the average in your daily life. And we find the mean by finding the sum of all the data values, meaning we add all the data items together, and then we divide by the number of items, or the number of numbers in your list. So in this example, I'm going to add those numbers together. I don't need to put them in order. 2 plus 12 plus 17 plus 11 plus 8 plus 12 plus 31 plus 15 plus 8 plus 21 divided by, I'm going to count how many numbers I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I divide by 10, the number of data values in my set. That gives me 137 divided by 10, which is 13.7. And that's my mean. The last of our 4 measures of central tendency is the mid-range. The mid-range is the midpoint of the interval created by finding the average of the minimum and maximum values of the data set. To find the mid-range, we're going to take the lowest data point and the highest data point and divide by 2. In this data set, our lowest number appears to be 2, and our highest number appears to be 31. So I'm going to add them together and divide by 2. 2 plus 31 divided by 2. I'm basically finding their mean. And we get 16.5. And when we say it's the midpoint of an interval, basically what it means is if you put these numbers on a number line and 2 is the lowest and 31 is the highest, the mid-range is right in the middle of that interval. So 16.5 would be right in the middle of 2 and 31. Another definition we need to discuss is the word outlier. An outlier is a value that is substantially different from the rest of the data in a set. If the data is in one variable, outliers can occur at the ends. They can be misleading because they can affect measures of central tendency. So one thing we want to explore today is which measures of central tendency are most affected by an outlier. So an outlier is a number that's either way above or way below the other data values in the set. So looking at this data set in number 5, we have lots of numbers in the 70s, and which number doesn't belong? The number 23 is an outlier because it's way below the other data values in the set. We're going to look at one more example using a frequency table. A frequency table lists a set of values and how often each one appears. The frequency is the number of times a specific data value occurs in your data set. In this example, 20 students took a math test with 10 questions, and their results were recorded in the following table. So if the test had 10 questions, this means that 2 people got a score of 6, 3 people scored a 7, 7 people scored an 8, 7 people scored a 9, and 1 person scored a 10. So if I were to list out these data values or the scores of the 20 students, I would have 2 6s, I would have 3 7s, I would have 7 8s, 1, 2, 3, 4, 5, 6, 7, I would have 7 nines. 1, 2, 3, 4, 5, 6, 7, and I would have 1 10. So if it's helpful and the frequencies aren't too high, you can make a list of your data values. But when your frequencies are really high, it sometimes is too tedious to list them out, and we might need to think of some other strategies. Now, to find the mean, I could add up all these numbers, 6 plus 6 plus 7 plus 7 plus 7 plus 8 plus 8 plus 8 plus 8 plus 8, and so on, and then divide the sum of all those numbers by 20. But a more efficient way to do that, since I have 2 6s, I can do 2 times 6, and 3 7s, so 3 times 7, and 7 8s, so 7 times 8. I have 7 9s, and I have 1 10. And so I can multiply and add and then divide by 20 because there were 20 students who took that test. I compute the top first and I get 162. Then I divide that by 20 and we get 8.1 for our mean. Now for the median, since I did list them out, maybe I want to find it using my list. We can also use that position trick. So the position, since I have 20 numbers, I do 20 plus 1 divided by 2. 21 divided by 2 is 10.5. So that means the median is between the 10th and 11th data values. Now I could, using my list, count to my 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. It would be these 2 8s right here. So the median is going to be the average of those 2 8s, which is just going to be 8. If I add the 2 8s and divide by 2, I'm just going to get 8. Now, using the position, I also could have, if I didn't want to list out my numbers or if my frequencies were really high, I can use the frequency table to find the 10th and 11th data values and where they would fall, what numbers they would be. So I know that my first 2 numbers are 6s. Then my next 3 numbers are 7s. Those are the first 5 numbers. So I haven't gotten to my 10th and 11th data values yet. If I add on the 8s, 7 more numbers, that would be the first 12 numbers. And my 10th and 11th numbers would be some of those 8s. And so I know that they would both be 8s, and the average of, or the mean of 2 8s is going to be 8. Now let's do the mode. The mode is the number that shows up the most or repeats the most. Now in this data set, there were 7 8s and 7 9s, so they tied for the mode. We call this bimodal when there are 2 modes. So 8 and 9 are both the mode. And lastly, we're going to find the mid-range. We take our smallest number, which was 6, and our highest, which was 10. We add them together and divide by 2. 16 divided by 2 is 8. And notice our mean, median, modes, and mid-range were all pretty close together in this set of data. Also, always make sure that your answers for these measures of central tendency are in the middle of your set of numbers. You should never get a number that's lower than the lowest value or higher than the highest value when you're trying to find the center. If that happens, it means you made a mistake and you need to figure out what your mistake was.